Hello everyone. In this video we're going to cover solving absolute value equations. Okay, and the good thing is we've solved equations a lot before, so this is a topic you're familiar with. The only difference is that now it's going to involve absolute value. Okay, now let's review first what absolute value is. The symbol for absolute value are these two vertical bars. And by definition, absolute value just means distance from zero. That's all absolute value is. A lot of you might remember it as it can't be negative because distance from zero can't be negative. So take, for instance, the absolute value of 3, right? That's how you read this, absolute value of 3. Well, 3 is right here, right? So absolute value of 3 just means how many units away from 0 is 3? Well, that's 1, 2, 3. So it's 3 units away from 0. So the absolute value of 3 is 3. What about the absolute value of negative 3? Well, negative 3 is here, right? So how many units away from 0 is negative 3? Well, that's 1, 2, 3, right? So the absolute value of negative 3 is still 3. So again, a lot of you might remember that absolute value just makes everything positive. So what happens now if instead of putting a number inside the absolute value bars, I put a variable, right? So now it's kind of going backwards. You know the answer is 3. So now what number would have to be inside the absolute value to make that true? So this is where it gets interesting. Just like we did here, absolute value of 3 is 3, and absolute value of negative 3 is 3. So basically, 3 was the answer for 2 different problems. So if you kind of keep that in mind, if the absolute value of x equals 3, then x could have 2 possible values. X could either be 3, right, because the absolute value of 3 is 3, or x could also be negative 3. So when we're talking about absolute value equations, we have 2 possible answers: a positive answer and a negative answer. So you have 2 possible answers. So that's really the big idea of absolute value equations. You have to take into account both possibilities. So it's really solving 2 equations in one. So let's see what that really looks like in an actual equation that you have to solve. I'm going to come back to these steps. I broke down the steps, but let's just look at an example first. You have the absolute value of x minus 3 equals 1. So here's my equation. So when you're solving an absolute value function, the first thing you want to ensure is that the absolute value is isolated. In other words, there should be nothing outside of the absolute value bars. So in this case, there's nothing outside, so we're ready to solve. So basically what ends up happening here is you take your absolute value equation, so say absolute value of x minus 3, just copying that over. So to solve it, again, you have to take into account the positive and the negative answer. So you have to split this into 2 equations. X minus 3 equals 1. And x minus 3 equals negative 1. So you're taking into account the positive answer and the negative answer. This is what I mean, it's just 2 equations in one. You basically split it into 2 equations, and then you just solve each equation for x. So on this one, I have to add 3 on both sides to get x by itself. So x equals 4. So that's my first answer. Or my other answer comes from x minus 3 equals negative 1. So here to isolate x, I got to add 3 on both sides. So x equals 2. So those are my two answers, x equals 4 or x equals 2, because either of those values will make the equation true. Okay, you can do a quick mental check. If I put a 4 here, 4 minus 3 is 1, right? So that would be absolute value of 1 equals 1, which is true, right? So if I plug in 4, it works. Now let's see what happens if I plug in 2. 2 minus 3 is negative 1. So then I have the absolute value of negative 1 equals 1. Well, that's also true. So either of those numbers will make the equation true. So that's why it has two possible answers. All right, so that's all there really is to it. It's two equations in one. Let's look at number 2. Absolute value of 4x minus 12, and then minus 3 equals 13. So think about what I told you earlier. You always want to make sure that your absolute value is isolated, so that there's nothing outside of it on that same side of the equals. Well, in this case, there's something outside of it. There's a minus 3. So you need to eliminate that before you start solving. So before you start splitting the equation into 2. So what you want to do here is add 3 on both sides and rewrite your equation so that you only have the absolute value of 4x minus 12 equals, if you add 3 on both sides, that would be 16. So now that my absolute value is isolated, now I can split it. Okay, so your step 1 is make sure there's nothing outside of it. So now I'm going to split it into 4x minus 12 equals 16, right? So that's my positive answer. And then the other one is exactly the same. 4x minus 12 equals negative 16. So the stuff inside the absolute value stays the same always. You just bring that down. The only thing you change is the sign in your answer. So one of them you keep it the same, the other one you make it negative. So those are your two equations that you need to solve. Just get x by itself now. So let's start with this one. First, add 12 on both sides. So that'll give me 4x equals 28. Divide by 4. So x equals 7. There's my first answer. Or, right, my other option, let's solve this one with a negative answer. Negative 16 plus 12, that's negative 4. Divide by 4. Divide by 4. So then x equals negative 1. So x equals 7 or x equals negative 1. Either of those values will make the equation true. Okay, now let me show you how you can easily check this. Your first option is to just plug it in the way I kind of showed you over here, where you plug in the number and see if it makes the equation true. That's the mathematically sound way of doing it, but there is a shortcut. You can actually use Desmos, and you can just type the equation exactly the way it appears in the problem. So let me check number 1. Here's the absolute value bar, right? It's right above the ABC. That's x minus 3. And then make sure you get out of the absolute value bar before you put the equals 1. And what Desmos is going to do is just going to draw two vertical lines. And what you need to do is just figure out where it crosses the x-axis. So you can zoom in. And because this is not really a function, it doesn't really draw the absolute value graph. So you also can't put a point here. But if it doesn't show you the number, just keep zooming in until you see what the value is. So right now I can see that it crosses at 2 and it crosses at 4, right? 2 and 4. So is that what we got for number 1? X equal 2 and x equal 4? Yep, that matches what Desmos says. So that was the check for number 1. For number 2, I'm gonna go in and graph that equation, that absolute value equation. All right, let me get absolute value of 4x minus 12 equals, minus 3. Don't forget the minus 3. You can just type the exact original equation. Equals 13. Right? And if it doesn't show it right away, remember you might want to zoom out, right? Well, you can always zoom in and out. All right, and as you can see, it crosses at -1 and it crosses at 7. And when I solved for it, that's exactly what I got. It crosses at -1 and, wait, was it 1 or -1? Yeah, -1. So it crosses at -1 and 7. So it checks out.